Hello everyone, I am Shubham and welcome back to the channel. Valid parenthesis. It's the number one stack problem you will see in interviews, not just once, constantly. Google, Amazon, Meta, all of them ask this. But here's what most people miss. It's not really about the parenthesis. It's about understanding the stack data structure and when to use it. Master this one problem and you can solve a lot of others using the exact same pattern. Let's break it down. Here's the problem. Given a string containing just the characters, parentheses, curly brackets, and square brackets, determine if the input string is valid. A string is valid if every open bracket has a corresponding close bracket, every close bracket has a corresponding open bracket of same type, and brackets are closed in the correct order. You can't close a bracket that hasn't been opened yet. We will try understanding the problem first. Let's start simple. Just an open parenthesis and a close parenthesis. This is a simple pair, same type and correct order. So this is a valid string. Coming to the next example, we have open parenthesis, close parenthesis, open bracket. Both are square bracket of same type, and then open curly brace and close curly brace. That's also a valid string. Here's where it get interesting. Nested brackets. We have open curly brace, open square bracket. Notice here that you have to close the innermost bracket first before you close the outer bracket. This is the key insight. This makes it a valid string. Similarly for the next one where you close the innermost bracket first before you close the outer bracket to make it a valid string. Now some invalid examples. Open parenthesis must close with a close parenthesis, not a square bracket. So this is an invalid string. For the next example, the square bracket is never closed. Once again, this is invalid. And this one, we opened a parenthesis, then square bracket. To be valid, we must close the square bracket before the parenthesis, but we are closing parenthesis next. Wrong order. So this is again an invalid string. This is the key constraint here. It follows a LIFO order. This is last in, first out. Let's start with the naive solution. When you first see the problem, you might think just count the brackets, and if the number of open equals the number of close, it's valid. For the example on screen, the open and close count is 1. This string is valid. Let me show you why this doesn't work. For the next example, we again have equal number of open and close, and the naive approach would return true for this. But wait, not square bracket, right? The actual answer should be invalid. And the naive approach failed here. It fails because it only counts. It doesn't track the order or the type. We need to know which bracket opened most recently, what type is it, and does the close bracket match. This is where the stack comes in. A stack is a data structure that works like a LIFO. That means last in, first out. Think of a stack of plates. You put plates on top of each other. You take plates off the top. You never take from the middle or from the bottom. Stack supports three main operations, which is push. So if you have a stack and you push some value, let's say 3, it will come to the top of the stack. And then we have a peek operation. This returns the value at the top of stack. So it will return 3. Then we have a pop operation which returns the value from the top and removes it from the stack. Here's the idea. We work through the string character by character. Every time we see an opening bracket, we push it to our stack. Every time we see a closing bracket, we ask what's on the top of the stack. If it matches the open bracket, we pop it off and continue. Otherwise, if it is not matching the bracket or if the stack is empty, the string is invalid. We can return false there and then. At the end, we should not have anything in the stack. Every open bracket was matched and closed correctly. That means the stack will be empty. In that case, we can return true. If the stack still has something in it, there were open brackets that were never closed, so that would cause an invalid string. Let me trace through our example again. We have open parenthesis, open square bracket, close parenthesis, and close bracket. I will create a stack on the right so we can see it correctly. We start with our first character. It's a open parenthesis, so we push it into the stack. Next, we see a open bracket. We again push it to the stack. Now stack has these two values. Next is a closing parenthesis. Let's say our current is closing parenthesis and the top is open square bracket. Does these two type match? No, right? We can return false immediately. So the stack got it because it remembered the most recent open bracket was a square bracket, not a parenthesis. Let's walk through another example to understand it better. We have this example as input, and I will create a stack on the right again. So we start with our current. It's a open curly braces. We push it to the stack. The next character is open square bracket. Is it opening bracket? Yeah, we push it to the stack. The next character is open parenthesis. Again, it's an open one, so we directly put it into the stack. The next element that we have is a closing parenthesis. Now we check what our top element is. Is it opening? No. And is the stack empty? No, right? So we pop from the stack. What's our top element? It's the opening. It's the opening parenthesis. Do they match? Yes. So we have removed it from the stack and move to the next element. Now next element, again, it's closing square bracket. We check the top from the stack. We pop it out. Does they match? Yes. So once again, we just move to the next element, which is our closing curly braces. We pop the element from the stack again. Do they match? Yes. Once you have iterated through the whole input and your stack is empty, that means the string is valid. See how it worked? Every time we hit a closing bracket, we found its matching opening bracket at the top of the stack, and at the end, the stack is empty, meaning everything matched. There could be few edge cases such as empty string. It's technically valid. The stack will remain empty throughout and would return true in this case. Another could be a single character, like just an open bracket. We will push it to the stack, and when we never see a close bracket at the end, the stack is not empty, so return false. That works. Another edge case could be starting with a closing bracket and followed by an opening bracket. In this case, when we check the first closing bracket, we would ask, is it opening? No. If the stack empty, yes. So in that case, we again return false. All right, let's start with the coding. Before you write the code, a Java specific thing I want to flag. There is a stack class in Java, which is java.util.stack, and most tutorials will tell you to use it, but don't. The Java stack class extends vector, which is a legacy class from Java 1. It is synchronized, meaning it's thread safe by default, which adds overhead you almost never need. It also exposes method like getIndex that don't make any semantic sense on a stack. The right tool is Deque, specifically array deque. It's faster, it's not synchronized, and it has the exact properties we need: push, pop, and peek. Even the Java documentation explicitly recommends using deque over a stack. Important thing, using deque instead of stack in an interview is a visible senior signal. It tells your interviewer you know Java's standard library well enough to know which parts are outdated. Most candidates use stack, you don't. Alright, before I type anything, here's what the code needs to do. We need a deque to act as our stack. We loop through every character. For opening brackets, we push. For closing bracket, we check the top. If it doesn't match or the stack is empty, return false. At the end, just return whether the stack is empty. That's it. Now let's write it. Let's start with creating our stack. This is where we store open brackets. We are waiting to close. Loop through every character in the string. To char array. For every open bracket we see, we push it to the stack. and deal with them when we see the matching clause later. Square bracket, we push it here. Otherwise, if it's a closing bracket, check if the stack is empty first. Empty stack means there's no open bracket to match, and that would be invalid. Pop the top element. This is the most recent unmatched open bracket. Then we check if the close bracket matches the open bracket we just popped. If our current character is close parenthesis and our top element is not open parenthesis, we return false. Let me copy paste everything. There should be curly braces, and then we have square brackets. At the end, we check the stack is empty. Empty stack means every open bracket was matched. Non-empty stack would mean there were some brackets which were not matched, and that would make it an invalid string. All right, let's try running it. Cool, it passed the initial test cases. Let's submit. Yeah, looks good. So it is accepted. Let's talk about the time and space complexity. Time complexity is order of n, where n is the length of string. Why? Because we iterate through the string once. Each push and pop operation on a stack is order of 1. So we do 2n operations at a most. That's still order of n. And the space complexity is also order of n. In worst case, if all brackets are open, we push all of them onto the stack. So we use on extra space for the stack. That's valid parenthesis. Why the naive counter approach fails, the stack solution, and what your interviewer is actually looking for. The stack pattern in this video is going to come up again and again in min stack, daily temperature, largest rectangle in histogram. Once you see it, you can't unsee it. If you have been watching the series from video 1, you are building a real toolkit here, not just memorizing solutions, but understanding the patterns underneath them. Drop a comment if you want me to cover the hashmap based solution for this problem as an alternative approach. There is an elegant way to handle the bracket matching without the if else chain. If enough people ask, I will do a follow up. Subscribe if this was useful. New video every week. See you in the next one.